Hello friends, I'm Dr. Meena, Assistant Professor, Department of Mathematics, KPR Institute of Engineering and Technology. Today we are going to discuss about the LU decomposition method. The LU decomposition method is a method to solve a set of simultaneous linear equations to find matrix inverses and computing determinants. It is particularly applied in many fields like structural engineering, computer graphics, and robotics. Any non-singular matrix A can also be written as the product of L into U, where L is the lower triangular matrix and U is the upper triangular matrix. So these are some steps to be followed to have the LU decomposition method. The first step is we have to convert the given simultaneous linear equations into the matrix capital A. Then the second step is we have to decompose the matrix capital A into the capital L and U. The third step, we have to solve L into Z equal to C for finding the value of Z. And the fourth step, we have to solve U into X is equal to Z for finding the value of X. So the matrix A is decomposed as the product of L and U, where L is given as 1, 0, 0, L21, 1, 0, L31, L32, 1, and U is given as U11, U12, U13, 0, U22, U23, 0, 0, U33. Now we can see an example to solve the simultaneous linear equations. So here is a set of equation. So here it is given by 25x plus 5y plus z is equal to 106.8, 64x plus 8y plus z is equal to 177.2, 144x plus 12y plus z is equal to 279.2. Now we are going to solve this simultaneous linear equation using the LU decomposition method. As I said before, in the first step, we are going to rewrite the given equation in the form of matrices. And then we can find the value of the upper triangular as well as the lower triangular matrix using the Gauss elimination method. So the matrix A becomes 25, 5, 1, 64, 8, 1, 144, 12 and 1. Now we can use the row reduction method to find out the value of the lower triangular as well as the upper triangular matrix. So first thing is we divide 64 by 25, we get the value as 2.56. So row 2 minus row 1 into 2.56, we get this following matrix. Now we are going to find out the upper triangular matrix once again by dividing 144 by 25 equal to 5.76. So row 3 minus row 1 into 5.76, we get this matrix. And then minus 16.8 by minus 4.8 is equal to 3.5. So row 3 minus row 2 into 3.5, we get the above matrix. So this is a upper triangular matrix, so which is given by 25, 5, 1, 0, minus 4.8, minus 1.56, 0, 0, 0.7. Now in the same way, we are going to find out the lower triangular matrix, which is given by capital L is equal to 1, 0, 0, L21, 1, 0, L31, L32 and 1. So L21 is equal to A21 by A11. The value of A21 is 64, A11 is 25. On dividing, we get the value as 2.56. In the same way, we can able to find out L31 is equal to A31 by A11. And we can able to find out L32 by using A32 by A22. That is equal to, we get 3.5. So in this way, we can get the lower triangular matrix value as 1, 0, 0, 2.56, 1, 0, 5.76, 3.5 and 1. So everybody is having the question whether the product of L and U is equal to the matrix A. Yes, of course, always the product of the lower triangular as well as the upper triangular matrix will be the given matrix A. Now we can come to the step 2. The step 2 is nothing but just we are going to decompose the matrix A into L into U. So that is, I have substituted the value L and U here. The next is the step 3. The step 3, just we are using the formula L into Z is equal to C. So here I have substituted the value of L, and Z is the column vector, that is Z1, Z2, Z3, and C is the constant values which is given in the equation. So the values are 106.8, 177.2 and 279.2. Now we can able to solve the value of Z by using the equations. Z1 is equal to 10, 2.56 Z1 plus Z2 equal to 177.2, and then the third equation. So we are using the forward substitution method to solve the value for Z. So using this method, we can able to find out the value of Z1, Z2 and Z3. So we can get the values as 106.8, that is the value of Z1. The value of Z2 is minus 96.21 and the value of Z3 is 0.735. Now, in the same way, we can able to find out the value of, that is x value. That is, we are going to follow the step 4 using the formula u into x is equal to z. So while doing the backward substitution, we can able to follow, or we are going to follow, that is value of x. So from the third equation, 0.783 equal to 0.735, we can get the value of A3 is equal to 1.050. Now we can substitute the value of A3 in my second equation, that is minus 4.8 into A2 minus 1.56 into A3 is minus 96.21. Substituting, I can get the value of A2 is equal to 19.70. In the same way, finally, we can substitute the value A3 and A2 in the first equation, that is 25A1 plus 5A2 plus A3 is equal to 106.8, and I can get the value as A1 as 0.2900. So in this way, I am getting the value of A1 is equal to 0.2900, A2 is equal to 19.70, and A3 is equal to 1.050. So in this way, using the LU decomposition method, we can easily able to solve the simultaneous linear equation. Thank you.